So yesterday or the last video, I don't know how I'm going to paste these. I have no idea. But in the last video, we talked about solids, liquids, and gases as the three phases of matter. And we said that solids had their particles close together, which means that they are highly compressible, they have a high density, and they have a small amount of movement. Remember, solids are vibrational and rotational movement only. Liquids are further spread apart. There is more movement between their particles. They move faster. They have a higher kinetic energy, which is the energy of heat. Liquids are warmer than solids, you know that. And then finally, we talked about gases and we said they're very far apart from one another. The particles travel really quickly and they have high compressibility because there's so much space in there. And we had talked about our three phases. The three phases of matter, though, can change from one to another. So that's what we're going to be looking at today. We're going to be looking at changes of state or changes of phase. If we start in a solid, that solid will start to absorb heat. And as it starts to absorb heat, the temperature rises. And that solid, the energy gets really, really strong. And that vibrational, rotational movement gets so strong that it breaks free of the solid state that it's in and it starts to form a liquid. And then the same thing happens with the liquid. It moves and moves and moves. The heat piles in. It's moving faster and faster and faster until it finally gets enough heat to eject off the surface of the liquid and evaporate. And so that's really what we're going to be looking at. We're going to summarize all of these phase changes in a diagram. And a little later on today, I'm going to assign to you to draw and label and color a phase diagram. So you should really be paying attention. You're going to make a phase diagram for me from like a blank piece of paper like this one. You're going to turn that into a phase diagram. So pay attention to the details. So here is a phase diagram, and we're going to look at this and talk about it for a while. Okay, so first of all, we can see that there is a line here that represents the pressure. So this is like our atmospheric pressure. The higher we go up, the more pressure is on the substance. This right here, this is our normal 1 atmosphere of pressure. This is where you and I live at this 1 atmosphere of pressure. Down here on the bottom of the chart, we have temperature, and this is in degrees Celsius, and we'll talk about what that means and what our degrees mean a little bit later. But 100 degrees Celsius is the normal boiling point of water. This is where water boils on a stove, in your house. This is the normal boiling point. So over here on this line closest to the pressure, we're always going to find the solid. Okay, on this line closest to the pressure. And then we're going to cross this line right here. When we cross this line is called either the melting curve or the freezing curve. It depends on which direction you go across the line. If you go from solid to liquid, it's a melting curve. From liquid to solid, it's a freezing curve. But this whole line is called the melting or freezing curve, and it separates solid from liquid. And then as we continue to heat up, right, we travel across our temperature this way. As we continue to heat up, we hit the condensing curve, evaporating curve, condensing curve. So this line right here from the triple point, we'll talk about that later, from the triple point all the way up to the critical point, this is called the evaporating curve or the condensing curve. And that separates liquids on this side from vapor on this side. In this case, this is for water. So we call liquid water, water vapor. And then right here, there's this little line that separates solid from gas. And we're going to talk about that line a little bit later, but that can be called the sublimating curve or the deposing curve. That's enough for this first phase diagram. We're going to go on to the next diagram, if I can get it to click. There it goes. So in this slide, what we're looking at is a whole bunch of vocab. Some you know and some you maybe don't know. So evaporating or boiling is when liquid turns to gas. Condensing is when gas turns to liquid. Melting, solid to liquid, think ice, right? Water solid is ice, ice to liquid. Freezing is when liquid turns to solid. And then we get these weird ones, sublimation and deposition. If you have ever seen dry ice, then you have seen sublimation. This is when a solid goes directly to the gas state. It skips the liquid state and it goes directly to gas. And deposition is the opposite. Under really high pressure, low temperature conditions, we're able to force a gas straight down into the solid state. This doesn't happen with water. It would need too high of pressure or too big of a temperature change. It does happen with carbon dioxide. So dry ice is carbon dioxide that has been forced into the solid state. And it is so cold and it so wants to be a gas that when you move it out into a normal environment, it just jumps directly up out of that solid state into the gas state. We call that sublimating or subliming. When something's sublime, like you jump out of your seat, okay, it's sublime. The last 2 points that we need to talk about are the critical point. This is a point on the heating curve, on the evaporating curve at the very end, where no matter how much pressure you put on the gas, it's so hot that it's all a gas after that. So the critical point is like where the curve ends. There's nothing past the critical point. Lastly, the triple point indicates where solid, liquid, and gas all coexist together. And this is a really weird point to think about, but if you can imagine a situation where you were at such a low pressure and at room temperature that you could have ice in liquid and the liquid would be boiling and it would all be existing there together. It's super weird to think about, but it is a real thing. And guess what? You have Google. So if you wanted to look up the triple point of water or a video of the triple point of water, you can be my guest. You could go do that right now. I bet it is more interesting than this video. You could go look at that one. So the last thing I need to show you guys in this little lesson is how to draw a curve. So what I'm going to want from you guys is a curve that looks like this one, very similar. So what we're going to do is you're going to have on a piece of paper, you're going to create a curve like this, and you should have the axes labeled. So pressure and temperature should be labeled. And we should see basically a Y. Okay, your Y could be, it doesn't look just like this. It could look more like the water one. The Y could be up higher. It doesn't really matter. It just needs to have this Y to it. And nearest to the pressure line, that's where the solid exists. And then in the middle is the liquid. And nearest to the temperature line, that's where the gas is. And I just want to take a quick second because I was fumbled with my words on that critical point. This is the critical point right here. And this is the point where the temperature has gotten so hot. Okay, this is the temperature. The temperature has gotten so hot that no matter how much pressure you put on the substance, it's going to be a gas anyway. Because it's so hot, it has so much kinetic energy, it's going to go be a gas anyway. So we have the triple point here is at point A. We have the critical point at point B. We have solid, liquid, and gas. You have your deposition and sublimation curve here. You have the melting or freezing curve here. And you have the vaporizing or condensing curve here. We also have the arrows showing the phase change on all of these points. We have the pressure on the axis. We have the temperature on the axis. And I'm going to want your drawing to look just like that. I'm going to want to see all of those points included. So every point that was on the previous slide should be represented on your drawing of your phase diagram. Okay? All right. Thank you guys, and I'll talk to you in a little bit.